Hi everyone. So this is the second videos for the inequalities and variation lecture notes for online week. As I promised, this is the solution to the what is this? The solution to the inequality problem number 3 and 4 of two variables. Okay, so take a look at this. You can pause your the videos and try to make sense of what I wrote here. Again, like I mentioned, that when you try to choose a point, which in this case I choose the point 1, 0 to let you know that you could choose something different other than 0, 0 that I have been demonstrating. Okay, so I choose 1, 0 this time, and I plug it in, and the answer is no. If the answer is no, it does not satisfy the equation, 1 is not greater than 7, then you have to shade on the other side of the point that I choose, okay? And in this case, for problem number 4, the answer is yes, so you choose the side that has the point. Okay, we're going to something new, and it's called direct variation. What is variation? We define direct variation is when a situation translates an equation to describe with this inequality. Okay, so let me see here. With this expression right here. Okay, what this expression say is that y vary as directly as s. Okay, so when you see or hear something like that, that is what the equation means. Okay, and you will have the k as a constant. Okay, so the term k is called a constant. Normally in a problem when you say y vary directly as s, you have to find the constant value and then rewrite the equation. So let's go into the examples here. Okay, example number 1 say, if y vary directly as s, as soon as you see this phrase right there, you're gonna know that the equation, okay, the equation of variation gonna have the form that look like y equals to some number k times s. Okay, so now we're gonna use these two clues right here to help us find k. Okay, if we have s being 5 and y being 2, then we can absolutely find k. Okay, k happen to be, okay, I'm run out of space here, so I'm gonna go up there. K happen to be 2 divided by 5. Okay, but that's not the answer. The answer is the equation of variation. Okay, equation of variation is this right here. Okay, that is the equation of variation. So I'm gonna go ahead and say that y is equal, and now I have the number k. Okay, I'm not writing down k, I'm writing down 2 over 5. X. Okay, so y vary directly as x by 2/5. Okay, and this right here is my answer. Okay, k is not my answer. Y equals to 2 over 5, s is my answer. Okay, let's take a look at the second example. Find an equation in which s vary directly at t. You see that? S vary directly at t. So that means s vary directly as t. So the equation gonna have the variation equation gonna look like this. And so here's some clue. When t is 15, s is 10. So I'm gonna go ahead and say that 10 is equal to k times 15. And I have to find out what k is. K turned out to be 10 over 15. Or simplify that, and k turned out to be, let me see, k turned out to be 2 over 3. So my variation equation is going to be s equal 2 over 3 times t. Okay, so that's the equation. And then the second part of the problem say, I'm going to use a different color to show you. Find the value of s when t is 32. Since I know that this is my variation equation, okay, then when I'm given 32, I simply plug 32 in and multiply with 2/3 to find out what s is. And this turned out to be, let me see, 64 over 3. Okay, so that's my second part of the problem. Any question? Well, I can't even see who has question now. So if you have a question, just hold on to your question, and then you can just go ahead and email me on Canvas, or ask Professor Martin when we resume from Thanksgiving break. Okay. Oh my goodness. Okay. The third example is an application problem. Let's read the problem for a moment. Okay. And the clue here is that it says the volume of soil required for a tree to thrive very directly at A, the area. So when you see that clue, you would know that you have a direct variation where the volume vary directly as the area. There we go. Okay, and then you have some clue here. It says that we see from the data here that when a tree has an area of 640 square feet, it needs a soil volume of 1,000 cubic feet. Okay, so using that information, you should find K. So the volume of 1,000 cubic feet have the area of 640. Okay, so in that case, if I solve for K, it's gonna be 1,000 divided by 640. And simplify that, I would have K equal to 25 over 16. Okay, but that's not my equation. The equation I have is V, which is volume, equals to vary directly at 25 over 16 times the area. Okay, then the real question here, let me do, I think I used the wrong color. Let's use black this time. It says, what is the soil volume if a tree have the area of 800 square feet? Well, I have the area of 800 square feet here, and I'm gonna just multiply with the constant, K, which will give me a volume of, let me see what the answer is. It gives me the volume of 1,250 cubic feet. Okay. All right. So that is all about direct variation. Okay. In the next video, I will show you what an inverse variation is, and it's a little bit challenging when you read an application problem and try to determine whether it's direct variation or inverse variation. Okay, so you might want to pay careful attention to the next video.